Hello and welcome to Core Concepts. In today's class, we're going to talk about some fundamentals of cryptography and securing information. The content for today's video is going to be cryptography, early examples of cryptography, different types of encryption or cryptographic algorithms, hashing, and so on. Cryptography. Cryptography is the process of securing your information and preventing any adversary from getting access to it or being able to tamper with your data. In order to understand cryptography, you have to understand two core concepts, encryption and decryption. Encryption is the process of taking a piece of information that you want to protect and scrambling it in a way that if anybody else has access to it, cannot read the information or cannot make sense of it. And decryption is the idea of taking that scrambled text and converting it to plain text. That's encryption and decryption. So the plain text is the text that you want to protect, and the ciphertext is the scrambled data, which we're going to use throughout this video. Those are the terminologies. Early examples of cryptography are Caesar's cipher and Atbash cipher. Cryptography and protecting information goes long, long back. And that's why we have like very old algorithms that were used to secure information. Cipher and Atbash are very simple cryptographic algorithms. Caesar cipher is focusing on shifting the alphabet n times to the right. That means like you can have shift 1 with Caesar cipher that converts every A in your text into a B, every B into a C, and so on. If you have shift 2, it will convert every A to a C, every B into a D, and so on. So you can play with that number and the algorithm will replace the text with your stuff. So if you look at this example, we have hello world. In the hello world example, H gets converted to I, E gets converted to F, and so on. And you can take the same data, feed it back to a reverse shift 1, and you get hello world. The other type of cryptography is called Atbash cipher. Atbash cipher is another simple one that takes the entire database alphabet and reverses it. So A becomes a Z, B becomes Y, so on and so forth. So if you feed hello world to this, it's going to give you this value, and if you feed back this value to a reverse Atbash, it will give you the hello world. These two are examples of symmetric algorithms. Symmetric algorithms are algorithms that you take one key to both encrypt and decrypt the data, to take the plain text and convert it to ciphertext, and take the ciphertext and convert it to plain text. A daily example of this would be if you want to use your house as a safe place so that you can put some piece of information or some tool that you want your friend to pick up. You can give a key, you can take a copy of the same key of your house, give it to your friend, you can use that key to lock your door, and you can ask your friend to go and just open the door with the same key and access the data or take the tool that you left for your friend. Asymmetric or public key cryptography is a little different. In asymmetric encryption, we use one key to encrypt the data. So we use an encryption key or a public key to take a plain text and scramble it and generate ciphertext. And you use the ciphertext, you use another key, which is called the private key, to convert the ciphertext into plain text. An example of this would be if you send an open box, lockable box, to one of your friends, you ask them to put something valuable in that, close it, lock the box, and send it back to you. The only person that will have the key is you. So your friend can use that box, which is the public key, to secure the information, and you will be the only one who will have access to open the box and decrypt the data. That is the idea behind asymmetric algorithms. There are two ways that you have to protect your data. One of them is called encryption at rest, the other one is encryption in transit. Encryption at rest is used when you want to store your data and like on a hard drive or on your machine or some sort of storage, and you apply some encryption technique to it, and you will protect your data. The protection that you get will be like if somebody gets access to your machine, or if somebody actually physically steals your hard drive, they wouldn't be able to make sense of the data. Remember, back in the days, the hardware was more valuable. Nowadays, the data is way more valuable than any hardware that you have, technically. The other type of information protection is encryption in transit. When you talk to a third party, like when you talk to Google, or when you go to Gmail or use any of these services, if you look at the address bar on the top of your browser on the left, you will see a lock icon. And if you click on that lock icon, it gives you a bunch of information about certificates and stuff like that, which we will probably cover in another future episode. But the idea is that that lock ensures that you and Google are communicating securely and nobody else can listen to that data. So in this example, Alice and Bob want to communicate. What they do is they establish an encrypted tunnel, and that encrypted tunnel uses some sort of encryption algorithm and cryptographic algorithms to encrypt the data and send the data back and forth between these two parties without anybody else on the public internet to know about it. Remember, every information that you send on the internet, if it is not on a secure channel, there are many hops on the internet or many people on the internet that can actually see the data. You don't want to do that. That's why we have algorithms and like protocols like SSL, TLS, and so on. Hashing is another form of, it is mostly used for data integrity. It's really not for securing the data. It's more for providing proof that your data is valid and has not been tampered with. Hashing is a one-way function or one-way process that takes a variable size text and applies a bunch of rules to that piece of text and generates a hash value or hash text. A good hash function will generate a unique hash value for any variable size of text. And this way, using hash functions, what you can do is you can send the data through a secure channel, and to add another layer of security, you can send a signature with this data, which is the hash value. And the receiver of the data, once they receive the data, they can apply the same hash function and get the same value. Remember, there are no keys in hash functions, and hash functions are not reversible. So if you get a hash value after you process a plain text, you cannot take that hash value and get the plain text back. It's not like cryptography. It's not like encryption and decryption. It's a one-way function that you go in with a piece of information, you get a fixed length data at the end, and everybody else will be able to apply the same to get the fixed data. And again, you don't need a key to do that. There are different types of hashing and cryptographic algorithms that are very famous these days and like have been there for a while and they're being used. We have for symmetric algorithms, we have AES, Advanced Encryption Standard, DES, Data Encryption Standard, that applies the data encryption standard 3 times technically, that's what it is. And for asymmetric algorithm, public key cryptography, we have RSA, which is one of the most famous ones. It is named after the creators, Rivest, Shamir, and Adelman. These are the guys who created it. And for hashing algorithms, we have MD5 and SHA. MD5 stands for Message Digest Algorithm. Again, like it's a one-way function. And SHA, we have different types of SHA, and we are going to talk about many of these in future classes. The next class, we are going to talk about a little bit of a history regarding cryptography and the crypto revolution and the idea of cryptocurrencies. Take care.